Watch your terminal for a moment. You send one prompt and the terminal starts printing out a sequence. It lists a directory of invoices, reads the files, tallies PIN numbers, and gives you a final sum. There is no orchestration code running on your machine making this happen. You are going to build this exact autonomous workflow using Claude Managed Agents, and it only takes 4 API calls from start to finish. To build it, you only need 3 things: the Anthropic SDK installed, your preferred code editor, and a valid API key. 3 of those 4 calls are straightforward setup. The 4th is where almost everyone gets stuck because it hides a sequence trap. Get 2 lines of code in the wrong order and your agent will seem to fail silently. Get those 4 steps right and you hand off the hardest parts of AI development. You define the task and Claude handles the tool loop on Anthropic servers. To see why this takes 4 calls instead of a single prompt, we have to look at the architecture. The system splits the work into 2 halves: durable resources that you build once and leave running on the server, and disposable sessions that you spin up for individual tasks. First call. Create the agent with a system prompt and specific model as your logic core. In that same call, a single configuration line switches on a massive pre-built toolset, granting instant access to Bash, file operations, and web search server-side. The server returns an ID string for this agent. You save that string because everything you do from now on will point back to it. Step 2 is creating the environment. This is the isolated secure container where the agent will actually run those tools you just authorized. Configure this environment, setting its type to cloud with unrestricted network access, allowing outbound access. The server replies with an environment ID. You save the environment ID alongside the agent ID. Those 2 strings are permanent coordinates. Whenever you have a new task, you tell the system to use the logic from this agent ID, executing inside this environment ID. With those 2 requests, your infrastructure is complete. You have provisioned a cloud container and wired up a tool-capable agent, and you never had to manage a server to do it. Now we look at the disposable half of the architecture. Step 3 creates the session. This is a temporary workspace spun up for a single task, and it links directly to your permanent agent and environment. The code provisions the workspace, but at this exact moment, the agent is sitting in a warm room doing nothing. It waits for your prompt. If you have worked with standard APIs, your instinct here is to send your prompt and wait for the response. But a session is a continuous 2-way stream. If you fire off your message before you attach a listener to that stream, you race the agent. Your script will either hang entirely or completely mess the agent's opening actions. Here's the logic chart showing how to avoid that trap. Instead, you must open the event stream listener first, and only then send your prompt. In your code, you write a stream block that creates an open context. You place your send message command inside that open context, followed immediately by a loop to catch events. As that loop runs, the session streams back specific event packets. The first is agent.message, printing its internal thought process. Next, you filter for agent.tooluse. This event tells you exactly which concrete commands the agent is running inside the container. Finally, you watch for session.status idle. That is the definitive signal from the server that the agent has finished its work, telling your script to break the loop and stop listening. Breaking the old request and wait habit and writing your code stream first guarantees you catch every step of a long-running agent's behavior. Now you run the script. Because the order is correct, your terminal immediately fills with the agent narrating its plan and reaching for its tools. You watch it call Bash to list the directory, open the files one by one to extract the numbers, and calculate the final invoice total on its own. You wrote 0 code to connect those steps. To verify how these components fit together before writing code, this is the Anthropic Console. You can prototype the exact same flow by simply clicking through the interface, letting you inspect the JSON shapes directly. Once your prototype runs successfully in the browser, you simply copy those durable agent and environment IDs directly back into your script. You have successfully deployed a fully containerized agent that completes complex tasks. But there is one final crucial detail. Sometimes an agent emits that idle status before the task is actually done. In the next video, we will look at how to read the hidden fields that explain exactly what the agent is waiting for.